Good morning. My name is Jennifer. I'd like to.
All right, good morning, everyone. Any questions from the homework? As usual, put them on chat or just say them. Okay, no questions? Everybody is fine? 3D, okay. So we have to find the integral from a half to the square root of 3 over 2 of 6 over the square root of 1 minus t squared dt. Okay, all right. Ideas. Anybody has any idea how to do that?
You would take the coefficient of 6 to the outside of the interval.
Absolutely. We always start with that to make things easier. 6 is a constant. It's a constant. Okay, we can start with that. Anybody else? Keep going.
The integral would then be sine inverse of x.
Exactly.
Or
So,
sine inverse of t.
right, exactly. So let us recall. But the goal of this exercise basically to remind you of the following fact is that the derivative of arc sine x in general, or t, it doesn't really matter, is 1 over the square root of 1 minus x squared. Right? So it's just, this is nothing more than a formula. So it's going to be 6 times arc sine t, because my variable's name is t, evaluated between a half and the square root of 3 over 2. So it was simpler than it looks. So that's 6 times arc sine square root of 3 over 2 minus arc sine 1/2. So this is equal to 6 times. Now, arc sine square root of 3 over 2, that's going to give me the angle whose sine is the square root of 3 over 2. So let's remember, the sine of what is the square root of 3 over 2? You guys remember?
Pi over 3.
That's pi over 3. So this is pi over 3 minus arc sine 1/2. It means basically you're asking yourself which angle its sine is a half. That's the arc sine or the inverse sine, which is the pi over 6. Right? And if we do the math, and if I don't move, we'll get 6 times pi over 6, which is equal to pi. All right, so we move on to your second question, 3F. Any question before we move on? 3F. We have to find the antiderivative of, oh, this is like the one I gave you yesterday in class, actually. Sine of the square root of y over the square root of y. So, of course, this problem screams substitution. And what should be the u? In a problem like this, even if I really don't see a derivative or anything, the minute I'm going to see the square root of y inside the sign, I'm immediately have to pick u to be the square root of y. Nobody want to deal with the square root of y inside the sign. So immediately u equals square root of y. And now the du means basically I need to find the derivative. The derivative of the square root of y, this is y to the power a half. It's a half y to the minus a half. It means 1 over 2 the square root of y. To make sure you can, and you know why this is the case. It means my du is 1 over 2 root y dy. So that's take care of the du. Now, this is a definite integral. I want to change the limit immediately, right? So we're going to change the limit. When y takes the value 1, so here change limit. When y equal to 1, my u is the square root of 1, which is a 1. When y equal to 2, my u is the square root of 2. I plug the value of y here in this expression. The square root of 2, I just keep it. I don't know what square root of 2 is. So this is equal to. Now everything substituted within the integral. The 1 stays 1. The 2 become the square root of 2. Sine of the square root of y become the sine of u. And now I have a piece, the dy over the square root of y. And I'm watching. I mean, you know, you guys, when you do substitution, you keep your eye on the integral and on the du right here, because you do have to do the substitution. Okay, if I keep my eye here, I realize that to get the 1 over square root of y dy, I need to multiply here by 2. So 2 du is 1 over the square root of y dy. So now I'm done. This is piece right here is the 2 du. So I'm going to have the 2 du. Question before we're almost done. Any questions? Anybody has any misunderstanding? Please feel free to ask any question you want. It's crucial. Now, 2 is a constant. I can pull it out. And I will have sine u du. So finally, this will give me 2 times. Antiderivative of sine is minus the cosine. This is evaluated between 1 and the square root of 2. At this stage, u is my variable. I don't go back to x because I changed the limit. So I have now a new integral in u. We forget totally about the original variable y. So finally, I will have minus 2 cosine the square root of 2, which is, I don't know what it is, and actually I don't care, minus 2 cosine of 1, and of the problem. Any questions? Can we solve 3e2? What's 3e? All right, we can do that, because that's my last day of review, and then I'm going to start chapter 6 today a little bit. 3e. So it's the integral from minus 1 to 0 of 1 over 1 minus 4x dx. Okay. All right. Saglam, what do you think the u would be?
I think we can get derivative of the denominator, but in this question, the thing that confuses me was the top of integral was smaller than the bottom of integral. So what I mean, like, for example, there is a 0 and -1 in the integral, but it was like 5 and 6.
Shall we else work it out? And when we hit your confusion, you let me know, okay?
Okay. Mm-hmm.
Okay, so I think I know what you mean. One, it doesn't really matter. It doesn't really matter. The bottom could be larger than the top. All right.
But I thought we are subtracting the
Okay, let's do it. Let's
bottom
do it.
from-
Let's do it. As I am doing it, you tell me exactly what's in your mind. Minus 4 dx. Okay, the derivative of 1 is 0, minus derivative of 4x is minus 4 dx. Now we change the variable. When x is minus 1, the u is 1 minus 4 times minus 1, which is equal to 5. When x takes the value 0, my u is 1 minus 0, which is equal to 1. And then this will become the following integral, totally in u now because I changed my variable. The minus 1 turns into a 5. The upper one will become 1. 1 over u. Now I need my dx. I have to pull it up from here, so I'll have to divide by minus 4 equal to dx. So times minus 1 over 4 d. And now I know your confusion that this is larger than that, right?
Yes.
Couldn't you flip the
It doesn't
interval?
really matter. You can flip it, you can keep it the same. It doesn't really matter. Okay, you can flip them, it's correct. And even if you don't flip them, you just apply the fundamental theorem of calculus the way it's applied, the value at the upper minus the value at the lower. Okay, so you can do it two ways. Either you flip, it means you take its minus from 1 to 5, absolutely correct. Or you apply the fundamental theorem of calculus verbatim by taking the value at the upper limit, which is a 1, minus the value of the lower limit, which is a 5. Either way.
Doesn't it fix itself anyway because you have a negative 1/4?
Does it do what?
Doesn't it fix itself anyway because
Yes,
there's a
yes, yes.
negative 1/4?
It does fix it. But still, let us say it is plus 1 over 4. You don't have to worry. That's my point. Okay, even if it's a plus, you apply it. It's at the upper minus the lower. So even if the upper is smaller, the fundamental theorem of calculus works. It's always the upper minus the lower. Am I answering those questions?
Yeah.
Okay. So the minus, even if you didn't pay attention to flip it, it doesn't really matter. So equal to. But I will flip it because you guys want me to. And then I'll tell everybody what we're talking about. What the students are telling me to flip is the following. The integral from a to b of f of x dx in general is minus the integral from b to a of f of x dx. Okay, so you can flip the limit, but you have to have a minus. So if I have a minus here, 5 and 1, and you guys don't like it, I can flip it. It becomes integral from 1 to 5, because I flipped those, of 1 over u du. But as I'm trying to tell you, you don't have to flip it. It doesn't really matter. You get exactly the same answer. So finally, it's 1 over 4, the natural log of u between 1 and 5. It means 1 over 4 ln of 5 minus the ln of 1. Now, if ln of 1, it's a 0. So I'm left with 1 over 4 ln of 5. And actually, if you didn't flip, let us see. If you didn't flip, let us see you didn't flip. I will use a pencil so I can erase. Let's say you didn't flip. So you're going to do it like that. So just to convince you that it doesn't really matter. Suppose you didn't flip. Then you would have minus 1 over 4 ln of u evaluated between 5 and 1. It's really actually the same thing. Because in this case, you're going to have the minus 1 over 4 ln of 1 minus the ln of 5. So it's like if you distribute this minus inside, you get exactly what you have above. So really nothing really changed. And that's what give me 1/4 ln of 5. Okay.
Professor, actually, questions about like 3H2, which is like, the question is if we get the integration of a trigonometric function, the values that we put to calculate integral, do we use radians or
Absolutely,
degree
absolutely,
values?
absolutely, absolutely. Calculus works with radian only. No degrees in calculus.
So, for example, integral 1 to 2 cosine x,
Yes,
when we convert to the
radian, absolutely radian. It's
Oh,
wrong
thank
in degree. I mean, there is a reason behind it. Probably it's hard to express it. You know, the derivative of cosine is minus sign, right?
Yes.
However, this is true if x is in radian. Okay. If the angle here is in degree, this is not correct. And it's a little subtle idea. Why? Because if we prove it, it doesn't work. I mean, the proof is that if x is in degree, I don't want to confuse you, but I want to make sure that you guys know that in calculus. If x in degree, the derivative of cosine is not quite a sine. There is a constant here. I forgot exactly what it is. It's like 0.87. It's a constant times the sine. So the picture change. It's the gradient which give me for the constant one. So that's why when we are saying antiderivative of sine is minus cosine, we're assuming the angle is in radian. So everything in calculus is true with radian. This formula fails when you are in degree. Okay?
Yes, thank you.
Absolutely. Now, anything else? Any other questions? So today we're going to move to chapter 6. I'll start introducing chapter 6, and then next time on Monday, hopefully not Monday, I think. Is Luther King on Monday or this Monday or the following? I forgot. Anyway, so chapter 6. So now we're going to go back to the book, absolutely, and the homework starting now will be out of my lab. Section 6.2, areas between two curves. Okay, let's see what we know so far. Okay, what we know so far is the following. First, let us recall that if f of x is a positive function, means to take only positive function on the interval AB, then the area of the region, bounded by, I'm going to introduce a new terminology, bounded by the graph of f of x, the lines x equal to a, x equal to b, and the x-axis is given by. So if f of x is a positive function, means only takes positive value, then the area of the region bounded by the graph of x. So let's see what I am talking about in the region. We have to get used to this notation. Okay, it's bounded by the graph of f. So let us say this is the graph of f. F of x is positive. The lines x equal to a, what do I mean by the lines x equal to a? Suppose this is a. The line x equal to a is this vertical line. So that's what I mean, x equal to a. The line x equal to b. if this is B, the line x equal to B is this vertical line. And the x-axis, I mean this line. So the way I'm going to describe this region, that's the new way we will be describing it. Bounded by the graph, the line x equal to A, x equal to B, and the x-axis. It means this region I'm talking about. And then in this case, the area is given by what? So what's going to be the area? It's given by the integral from A to B of f of x dx. That's what we know so far, because of the meaning of the integral. The integral means the sum of the area of those rectangles, because that's what the Riemann sum represents. So really, that's really what my integral means. So the area is given by this integral. As long as my function is absolutely positive, this definite integral is the sum of those, the area of those rectangles when we take a lot of subdivisions. So that's really what the area is. Okay. So for example, fairly trivial example. Find the area. Find area of the region bounded by the graph of f of x equal x squared minus 1, the line x equal to 1, x equal, let us say, to 3, and that's it at the x-axis. Okay. What's going to be my first step, do you think, in doing those problems? Graph. Okay, we have to graph just to see what we are talking about. The graph of is bounded by the graph of x squared minus 1. Now, x squared minus 1, that's the graph of a parabola. Parabola which is shifted down by a unit. So it's going to start from here as going up. So that's this parabola. That's my parabola right there. Of course, there is another piece, but I know that I'm not going to be interested in. The line x equal to 1. Now, what is the line x equal to 1? This parabola x squared minus 1 touches the x-axis when x equal to 1. Because of x equal to 1, I have a 0. So this is my 1, and this is my 3. So this is the region I am interested in. F of x, the function is positive in this region. Very crucial. The function is positive in this region. So the area is, so f of x is positive on the interval 1, 3. So the integral, so the area is the integral from 1 to 3 of the function x squared minus 1 dx. And now, because we know the fundamental theorem of calculus, we don't have to estimate the area using Riemann sum anymore. We can use the fundamental theorem, which will give me 1/3 x cubed, antiderivative of x squared, antiderivative of x is 1, sorry, is x evaluated between 1 and 3. And we do the math. It's going to give me 27, so it's going to give me 9 minus 3, it's a 6. Minus 1/3 minus 1 is, I don't know, I think it's plus 2/3, give and take some stupid mistake. All right, so if the function is positive, we are really fine. Now, before I introduce chapter 6, let me ask you the following question. Suppose I take the integral from minus 1 to 3. I evaluate this integral. Sorry, from 0 to 3. What does this integral represent graphically? Back to you.
It would be the area under the curve and on top of the curve.
So I'm gonna call this region R1, okay? I'm gonna call this region R2. Now, using R1 and R2, repeat your answer. Repeat your answer, don't worry.
You have to subtract R1 from R2.
Exactly. So it's not the area of those regions. It's not anymore the area. As we said last time, it's minus the area of R1 plus the area of R2. So so we have to be very careful when we're dealing with areas. We have to make sure that if you want to use the integral, we have to make sure that actually the function is positive in this interval. Okay, so now let me ask you the following question. Let us say I am interested. So we took care of that part. All right. Now suppose I'm asking you the following question. Let's say I'm interested in the area of R1. So it's the same problem. I'm not going to change the problem, but my question is find the area of the shaded region. This is my shaded region, and I'm going to ask you find the area of the shaded region. How would you do that? Back to you. It's the same problem. And my question now is find area of the shaded region.
Wouldn't the integral be defined at 0 to 1?
Make yourself a little bit more clear so I can actually understand. Go ahead, repeat. I want the area of the shaded region. It means I want the area of R1 plus the area of R2. How do you think I'm going to do it?
Is it the negative integral from 0 to 1 and the regular integral from 1 to 3?
Absolutely correct. Absolutely correct. Let me repeat what he said. We have now two regions, and we have really a problem here because up to here, the function is taking negative value. From here to here, the function is taking positive value. So the area of R2, I have no problem, no issue with it. It is the integral from 1 to 3 of x squared minus 1 dx because the function is positive here. However, the area of R1 is going to be minus the integral from 0 to 1 of x squared minus 1 dx. The reason it's minus because the integral give me minus the area since the function is positive because the function f of x, I'm hiding, is negative on the interval 0. Okay. Now I have the area of R2, I have the area, so the area of shaded region, once I compute both integral of the shaded region, is minus the integral from 0 to 1 plus the integral from 1 to 3. Okay, so we have to be extremely careful when we're dealing with those integrals. Okay, so that's what basically we know so far. Any question? Please, it's crucial that you understand what we're talking about. Please, any question, anybody? So the idea is that the integral from 0 to 3 does not give me the area. It gives me minus this, the area of R1 plus the area of R2. If I want the area here, I have definitely to split my integral. From 1 to 3, it's the regular integral, x squared minus 1 dx. Between 0 and 1, I have to take minus the integral because the function is negative. Okay. Now, what we're going to do for next, for section 6.2, what we're going to consider is the following. So I have 1 minute to tell you what we'll be talking about. What if I take one function, g of x, and I take another function, f of x. Okay. This is A, this is B, and this is my upper function or the top function, and this is a lower function. And now the question is how to find the area between them. That's going to be the content of section 6.2. We're going to try to find the area between two regions. Okay. All right. I definitely stop at this stage. We're going to start the quiz. A lot of you hasn't registered to my lab. Please do it. Please go ahead and do it. By Monday, I want everybody to be, to be registered. Any question before we start? All right, now I want you all to do the following for me. Go to Brightspace. Go to Brightspace, everyone. And then go to the content page. Are you all with me? Okay, on the content page, there is a module called quizzes. Click on it. Is everybody with me?
Yes.
Okay, then you will find the quiz there. Did you guys find it? Click and open the quiz. Okay. But this is your quiz. If you want to print it, fine. If you don't, it doesn't really matter. What I care about is that you write the answers very clearly on a sheet of paper. You will be judged for your work. Okay, so that's what I will look at it. So if you give me answer without work, I'll just scratch it. I will not really even look at it. And then once you're done, you either take a, you can use your camera to take a picture of it or whatever other way you want, and you upload it into Brightspace. All right. I will stay with you all this period. If you have any questions, you can ask. On chat, please privately. Okay, good luck.